Hello, all. This is Dr. Dave Maslach talking to you about reciprocity.com. The E is written with a 3. And in this particular video, I actually want to talk to you about the peer review process and give you kind of a definition of the peer review process, and then get into why peer review is actually really important for science. So this is part of my Nerd Out Wednesday series. This is stuff, so if you don't know, I'm actually a professor of innovation strategy and entrepreneurship. And this is stuff where I just talk about on every Wednesday. I've been talking about things that I find interesting in science. And in fact, I was so infatuated with this particular topic, the whole peer review process. I thought I'd try to create some sort of web platform where it was kind of like a sharing economy proofreading platform, where it was very similar to what was going on with the peer review process. I think it works amazingly well. And it does an amazing job of sort of vetting your work, right? So I'm going to get into, first of all, define what the peer review process is, and then finally get into why it's important, and then, maybe sort of describe how it generally works. It's different and it's pretty unique in terms of what actually happens in each sort of peer-reviewed article and each journal that you send it to. There's definitely lots of differences, but this is kind of generally the way that things work. At least that's what I kind of know at this moment. So what is the peer review process? So the peer review process is where, so you as a scientist have a really cool research idea and you write it up in a paper. So you find some evidence, you write it up in a paper. It doesn't necessarily have to be empirical evidence. It could be just a really cool idea. And you send it off to a particular article or a particular journal. And then when that happens, the idea gets vetted by both an editor at the journal and as well as some blind reviewers that don't know who you are and you don't know who they are. So this external audience, the reviewers, the peer reviewers, are generally very conservative. They are extremely knowledgeable with the thing that you're investigating. So the editor is going to send it to people that are very knowledgeable. They understand what you're doing. They are somebody that is, there's not that many people in this world that understand what you're doing, but the editor will find those people and send it to those particular people. And they will give their sort of 2 cents on whether they prefer the idea. And if they don't prefer the idea, where are some issues that they think are, what are the main issues with the particular idea? And it could be anywhere from a half a page to even 5 pages I've seen in terms of their comments that they can write down. The reviewers will write down a tremendous amount of information. What they're trying to do is just pick apart the flaws. But then if they are a very good reviewer, what they're trying to do is actually help you develop that particular idea even more. So I would even consider this as important, and a lot of people don't necessarily emphasize this as much, but I would consider this entire process as important, if not more important than the whole scientific process itself, or the scientific method itself. The whole idea of coming up with hypotheses and testing those hypotheses and then publishing or getting that information out there. Well, this whole process of some skeptical people that don't really know who you are, that are very knowledgeable and that they're going to critique your idea is very important for the whole process. So it would be so important that you probably don't necessarily, to some degree, it doesn't have to be sort of scientific. And in fact, a lot of qualitative research, for example, is not necessarily, they don't follow this sort of scientific norm where they would go and, hypothesize what's going on in the world, sort of do this deductive science. But they would go and they would kind of ask people, what their insights are, and then they draft up the insights from that qualitative research. So with that particular dimension or that particular way of doing research, it doesn't necessarily fit the scientific method, all that well. So the thing that sort of saves them is actually through the review process, and improves the science is through the review process. So normally when you do this whole process, and again, the reviewers are extremely conservative and they are very, very knowledgeable. And they are, if they're very good reviewers, they're going to be constructive. So they are going to help you out as much as they possibly can. I'll get into why that is in a moment, but basically the whole process, how does the whole peer review process work? Well, you send it there. You send it to the journal. The journal editors will send it to so the editors could be an associate editor, they're called. And then those people will send it to reviewers. The reviewers will then, they will go through the process and they'll read your paper and then they'll come up with different critiques. And once they do that, they'll either recommend to the editor whether they should reject the article, whether they should, go through major revisions with the article. Could be also called minor revisions sometimes, but most of the time you can get major revisions. You can also get, maybe it is a conditional accept, where they will say, yeah, this is good, but you have to do A, B, and C. There's a bunch of sort of different criteria you can go through, but generally it's or different sort of check marks that they could do, but generally it's going to be either you go through, they either say accept or, do what's called a revise and resubmit, and then they'll send it back to the editor. The editor will then, the associate editor or the editor will go through and they'll say, these reviewers are really like what's going on, because they'll be sent out to maybe, at the minimum one reviewer, but that's not ideal at all. But generally it'll be 2 to 3, even 4 reviewers. It could even be more than that. Some journal articles I've seen, I want to say like American Journal of Sociology has this really unique process where they will first send it to a set of reviewers. I might be wrong on the journal, but they'll send it first to a set of 3 reviewers, and then you'll go and do those revisions, and then you'll have to send it back in, and they'll send it to another 3 set of reviewers. And so what that's doing, it is adding an extra safeguard, and it is really being very rigorous in the science. And they'll pick apart all these different issues, right? So the reviewers, it'll be sent to 3 different reviewers, and the editors will sort of synthesize that material, and they'll say, okay, well, the reviewers seem to like this, and I'll give it a chance, or we'll give it a chance. And then we'll ask for a revision, or they'll say, the reviewers don't really like what's going on, so we're going to have to reject it. And then they'll reject that article. And you can't send it back into that. You can't send the same article back into the same journal. It's just not part of the scientific norm. You can, but there is a sort of reciprocity that happens within the scientific community, in that they all kind of know who you are. And it is necessary that you don't necessarily burn the sort of credits or credentials that you have. That's why the whole reciprocity platform is sort of set up in the way that it's set up, if you check it out. But really what it is, we have a certain amount of sort of credibility that we have. And if it gets rejected, then we should send it someplace else. But the editor can also say, yes, I like it, but there's so many issues with what's going on here. We have to improve it. You have to do all this stuff. We'll give you a major revision, but then you have to go through and revise all of this kind of material. And when you get it back as an author, you're like, this is amazing. But at the same time, you're like, oh my God, I have so much more work to do. We have to go through and do all this kind of stuff. And you have to, go through all of this work, get it done, send it back in. Once you make all of those revisions, it could be anything. It could be going through and changing the whole entire paper. It could be collecting new data. It could be, doing a bunch of new experiments. It could be revising the text. And it really is the norm. It is completely normal for them to ask you to basically do an entire new paper, at least within the first revision. And that is, you're going to have to reanalyze data, you have to rewrite things up. That's totally normal. At least in my field, it might be different in other fields. So in my field, in strategy and innovation, in organizational theory, totally normal to do that. And that's acceptable. And so you'd send it back in, and then you'd go through that process again. And the reviewers will say, I like this, I don't like this. And you keep doing that until there is somewhat of a consensus. And it's likely that there's never going to be a complete consensus with what's going on. It's just, everybody has their own feels on a paper, but there is going to be somewhat of a convergence that happens between the reviewers and the editors. And there's also a senior editor too that normally would go through and say, is this sound or not? So there's lots of checks and balances. There's a tremendous amount of checks and balances, and that's really what it is. And then eventually through the whole review process, you will get your paper accepted, and then you're like, wow, this is amazing, right? So the scientific process is in process and it's working. You can notice that the whole scientific method, is not sort of part of this process. It's actually much more similar to maybe the judicial system, where there's all these checks and balances along the way, and it's made to be very conservative, and that's a good thing, right? Because you're trying to improve the validity of science as much as you possibly can. So there's a couple of things that really improve the peer review process with this and make it generally pretty sound. So if I didn't mention it already, the peer reviewers are generally, it's double blind. So I don't know, when I send my stuff in, I don't know who they are. The reviewers are, and the reviewers don't know who I am. And that makes it really quite rigorous in a lot of different ways, because that they are going to be unbiased with their decision. They're not going to say, oh, I really like this scientist. They're going to say, this scientist is amazing, so that they should actually, I'm going to help them out in some sort of way. No, it doesn't work that way. Generally, it's pretty blind. The only person that knows what's going on is the editor, and they would know who the two different people are. But they try to be, generally, editors are extremely well-respected people in the field. So if they do anything that is not like kosher in any sort of way, it's not going to benefit them. So they try to avoid that kind of stuff. They're really unbiased with the stuff that they do. But they do try to help out ideas, and they try to help out, the whole review process is to help out to generate ideas as much as possible. It's really developmental in a lot of different ways. It seems really rigorous, and it seems like, just torture doing it, but it's really developmental. And the reason is it's all based on reciprocity, right? That if you send something in and somebody's not doing their job and not developing your work, then that you're going to be annoyed, right, as a scientist, or I'm going to be totally annoyed with that journal. I'm never going to send something in there again, right? So there's this whole reciprocity aspect of it. And then when somebody sends me an article to be reviewed, I'm going to spend a lot of time and go through and make sure it's actually, they're getting a good developmental. So I'm going to spend some time to try to think about their idea as much as I possibly can, to help them out and to push that particular idea forward. Because really, at the end of the day, scientists just want their work, they want their work reviewed and they want it out there in sort of in the public sphere, and they want to make sure that it is valid, right? That is as valid as you possibly can. They most scientists want sort of good science, and they want that good science out there such that other people will pick it up and they will read it and they'll say, well, this is really interesting, and they'll have a larger audience. And then you will attract followers, just like on Facebook and things like that, right? Where you're trying to get followers, and your Twitter or whatever, you're trying to get followers. And that's really what scientists are trying to do, because they want to show how cool their idea is and how important that idea is. And the whole review process sort of develops that idea. So any particular paper, any scientific paper that you ever read, it is not just from that one scientist. It's not from that one university. I hear that all the time. It annoys me tremendously. It's not the university that is producing that knowledge. It is actually the community of scientists and the community of researchers that are producing that knowledge. So the scientist actually has, they have some influence, right? So a scientist would have 50% of actually the idea. They'll go and they'll generate this idea, and 50% of it will be their idea. But then when you send it through the review process, the reviewers, which are totally anonymous, right? They are never ever going to get credit for this, other than maybe there'll be a little short note saying, "Oh, thank you for the anonymous reviewers," and they'll be kind of smugly thinking behind the scenes, they're like, "Oh, I really helped that idea. That was really cool," but they'll never know who that is. And so 50% of the ideas, almost every time, it's 50% of the ideas actually comes from the reviewers. I'm like, I never thought about that. That was a really cool idea. I should have thought about that, but the reviewers pointed it out. And then on top of it, then the editors, if they're really smart and they're really sound, they'll actually say, "Oh, I see where you're coming from, and I see where the reviewers are coming from, and you guys should go like this, and you're going to have a really cool article." And so then you go and write that up, and then you send it back in, and it is a really cool article when that happens. And that article would not have happened at all without the peer review process. And now a lot of people complain about it, and it's a stinker when you go through the whole process, because you're just having to do a lot more work. But at the same time, that work is really developing the scientific idea, and it's getting amazing when that happens, right? When you get that idea that is far better than what you could have done, you thought of yourself. You're like, wow, I'm really appreciative of the whole entire review process. And that's why it's so important to the scientific method, and it's so important to science. Is that it really helps you to think of new ideas and help you develop new approaches that you would never thought of before. So the whole peer review process is very important. So this video, I gave you the definition, at least from my perspective, and what do I know, right? So I gave you the definition of the peer review process, and then told you about why it's so important to science. So again, this is part of my whole reciprocity project. The E is written with a 3, where I'm just trying to help out people in trying to do good science as much as they possibly can, particularly like graduate students and things like that. I'm trying to advance science as much as I possibly can with this particular platform. So you could check out some of the stuff what I'm doing by watching some of these videos, as well as do subscribe to these videos. I do appreciate it. Give me a thumbs up if you like this video and this idea. At the end of the day, what I'm trying to do is actually make this whole review process easier to get your work sort of vetted and get some peer feedback through the reciprocity project. Before, to just get some feedback with your writing and things like that before you actually go through the whole scientific process. So that's it. Take care and have a wonderful day. All right. Bye.